Okay, so this looks like it could be a very tricky one, but what we're going to do is first of all factor these two quadratics. And so this one you may recognize as a perfect square. It factors to x minus 5 times x minus 5. This one we can factor. We need a product that equals positive 40, a sum that equals negative 13. That would be negative 5 and negative 8. So negative 5, negative 8. Well, notice we have three factors of x minus 5. So we could rewrite this as x minus 5 to the third times x minus 8. And this has to be less than 10. Well, this is much easier. It's much easier to deal with things in this form because all we have to do is figure out what the value of x minus 5 is and what the value of x minus 8 is, and then cube the first and multiply them together. So for 3, let's make a little column here. X minus 5 cubed, x minus 8. So for x equals 3, we'd get negative 2 cubed is negative 8 times negative 5. Product is positive 40. Greater than 10 doesn't work. X equals 4. We'd get negative 1 cubed is negative 1 times negative 4. Negative 1 times negative 4 is 4. That does work. If we plug in 5, we get 0. 0 is less than 10. That works. If we plug in 6, we get 1 cubed 1 and negative 2. So negative 2, of course, is less than 10. So that works. If we plug in x equals 7, we get 2 cubed is 8 times 7 minus 8 is negative 1, so that's negative 8. That also works. That's less than 10. If we plug in 8, we get 0 here. So everything is 0, which is less than 10, so that works. If we plug in 9, then we get 4 cubed is 64 times 1. Well, that's 64. That's greater than 10, so that's not going to work. And then we kind of suspect that 10 is not going to work. We get 5 cubed, 5 here, 5 cubed. We don't have to figure out 5 cubed is something big times 2. So we're going to have something big and double it. Of course it's going to be bigger than 10. That's not going to work. So the ones that work are the ones in that middle range, B, C, D, E, and F.
All right, let's just move our equation down here. Now our first step should be to eliminate the square root on the left-hand side. We can do this by squaring both sides of our equation. From here, the left-hand side simplifies to be 8x squared plus 17, and when we expand and simplify the right-hand side, we get the following. Since we now have a quadratic equation, we should set this equation equal to 0. So first, let's subtract 8x squared from both sides, and now we'll subtract 17 from both sides. At this point, we can factor the right-hand side as follows. Now, if x minus 13 times x plus 1 equals 0, then either x minus 13 equals 0 or x plus 1 equals 0. If x minus 13 equals 0, then x must equal 13, and if x plus 1 equals 0, then x must equal negative 1. At this point, it appears that we have two different solutions. However, when we check our solutions, we see that the second one here is an extraneous solution. So there's only one solution, x equals 13. Now before we go up here and enter 13, we should recognize that the question asks us to find the value of 2x. So since x equals 13, 2x must equal 26. So this is our answer. Okay, our goal here is to solve this equation for k. So we'll begin by plugging 2k into our original function. At this point, we'll simplify the numerator of our fraction. And now we can eliminate the 2 in our denominator by multiplying both sides of this equation by 2. At this point, we should recognize that we have a quadratic equation, so we'll set this equation equal to 0. At this point, we can divide both sides of our equation by 4 to simplify our quadratic. And now we can factor the right-hand side as follows. So if k plus 3 times k minus 2 equals 0, then k equals either negative 3 or 2. So as you can see here, our answer must be A. Our task here is to evaluate the sum of these two fractions. Now we can often gain valuable insight into questions like this by combining our fractions into one fraction. So let's do this here. First, we'll need a common denominator of xy. And now we can write our equivalent fractions. And now we can add our numerators. Notice that the numerator here is x squared plus y squared. And earlier we are told that x squared plus y squared equals 12. So we now know that our numerator is 12. Also notice that our denominator is xy. Well, we are told that xy equals 5, so our denominator is 5. We now need to take this fraction and rewrite it as a mixed fraction. This is equivalent to 2 2/5, so our answer is A. Okay, let's place our equation over here. And we'll begin by multiplying both sides of our equation by x plus 1. Now at this point, you might feel tempted to try to solve this equation for x. But this is unnecessary. Instead, let's add x to both sides. And now notice that this portion of our equation is very similar to the expression that we've been asked to evaluate. All that's missing here is minus 3. So let's take this equation and subtract 3 from both sides. When we do this, the right-hand side becomes x squared plus 2x minus 3, and the left-hand side becomes 5. So we can see here that x squared plus 2x minus 3 equals 5. So our answer is D.
Okay, which of the following is the value of x that makes the expression equal to 0? Now keep in mind that a fraction equals 0 if we have a numerator equal to 0 and a denominator equal to something other than 0. That will equal 0. But if we have 0 over 0, that's mathematical nonsense. That doesn't equal anything in particular. So 0 over 0 does not equal 0. Very important to realize. So we have to make sure that we're making the numerator 0 without making the denominator 0. And in order to figure that out, we're going to factor everything. So that first quadratic, x squared plus 5x plus 6, we have 2 times 3 is 6, 2 plus 3 is 5, so that factors into x plus 2 and x plus 3. The second, x squared minus 6x minus 7x plus 6, well, negative 6 and negative 1 multiply to positive 6 and add to negative 7. So that's going to factor into x minus 6 and x minus 1. Finally, on the bottom, we have x squared minus 4x minus 21. For that, we'd need a negative 7 and a positive 3, because negative 7 times positive 3 would be negative 21, negative 7 plus negative 3 would be negative 4. So this factors into x plus 3 and x minus 7. Notice that we cannot cancel the factor of x plus 3 in the numerator and the denominator, because right now we don't know the value of x. And if x equaled negative 3, then we'd be canceling 0 over 0, which would be illegitimate. You cannot cancel variables if you're not guaranteed that the expression does not equal 0. And we're not guaranteed that. So now we'll look at all the possible values. So first of all, x equals negative 6, that doesn't make anything equals 0. X equals negative 3, this is the tricky one. It makes the numerator and the denominator equal 0. And again, 0 over 0 does not equal to 0. Plugging in negative 3 would make the expression equal something that does not have a sensible mathematical value at all. So we get rid of that. If we plug in negative 2, then x plus 2 equals 0, and everything else is fine. So we have 0 over something, that's fine. If we plug in x equals 1, then x minus 1 equals 0, everything else is fine. If we plug in x equals 4, nothing goes to 0. If we plug in x equals 6, then x minus 6 equals 0. So we get 0 in the numerator, something in the denominator, that's fine. If we plug in x equals 0, then we get a non-zero number in the numerator, but 0 in the denominator. And that is also mathematical nonsense. So that doesn't equal 0 either. And so that doesn't work. And so the three ones that legitimately make the fraction equal to 0 are C, D, and F.
Alright, this is a pretty tricky question. One approach here is to use substitution. However, if you use substitution, you will quickly find that you have a very unpleasant quadratic equation which requires the quadratic formula to solve. This, of course, could be very time-consuming. The faster approach is to begin with x minus y equals 5 and square both sides of our equation. Now let's expand both sides to get the following. Now notice that if we add 2xy to both sides of our equation, we get x squared plus y squared on the left-hand side. And we've been asked to evaluate this expression. Well, we happen to know the value of xy, it equals 7. So we'll replace xy with 7. And finally, we see that x squared plus y squared must equal 39, so our answer is B.